I will pass to you later on. Huh? All right.
Okay.
Okay. For the sensor, rain sensor, you use particularly rain sensor. Rain sensor, we detect the rain line, the rain coming. So we detect the rains, whether they're using the wet, the condition is wet or not. So when raining, the sensor will detect that condition. So like our eyes or our nose or our ears, so we will have used that one to sense everything in our environments, nearest to our environments, to help ourselves to react, So, for example, our eyes, when we see something, that is the like a photosensor. So we can see, and then what the sense or the what we saw, where is it goes, the data or the signal. So where
Brain.
it goes, huh?
The
To brain.
brain.
So we have brain here. So brain. So brain, they do the processing. To process the signal. So the sensor signal, we go to the brain to make a interpretation whether because maybe in the sensor we have a condition 0 to 1, maybe rain. The 0 below, maybe not rain. So depend to the condition of the sensor, rain and not rain. So this data we send, or this signal we send to the brain to process. So in our part, this one, in our mechanicals, in our mechatronics or electricals, engineering side, we use this one as a computer. Computer, or what you call it? We can use also like what you call it, the data processing. So data processing or control system also we can use control system. So control system, computer, you can choose anything like Arduino, Python, computer itself, mini computer, PLC, to programming and to do a logic sequence. So when 0 to 1, logic is rain. Below that one, logic is not rain. That is the logic order, the condition we can interpret from the sensor. If without that one, we cannot do an interpretation. That's useless. Sensor is useless without the computer or the processing compartment. So after we process, this one we call input. So what we have output. So what we do with the output, we connect with the something can realize what we do with the sensor. For example, we see we see the phone. So our eyes detect the phone. So what we want to do, the brain will do a processing. Oh, please take the handphone. So our hand will take the phone, and then we do a something lah, to read news, do WhatsApp or whatever. So we send the signal to the motor. So the motor we do the processing, or we do the not processing, to do the work based on the processing data. So the motor will, so when we say the condition is this one, 0 to 1 is the raining, the motor we will turn, for example, retract. So because the motor, the function is turning clockwise until clockwise, for example. Clockwise, they're turning like this. Anti-clockwise, they're turning like that. So for the raining condition, the motor will turning like this. So when we turning like that, So the retraction process will begin. So because the running, the condition is 0 to 1 is the running, the motor will rotate to clockwise to make the retraction process. But when not running, the signal also will send to the brain, and then the brain will process, and then it's also sent to the motor. So now the condition is a vice versa, anti-clockwise turning. So the motor will extend to the a better condition, the outside the door or whatever to do. So the process is simple like that, because from sensor condition, you make a condition number 1 and number 2. Number 1 is for running, number 2 is not running. When number 1 begin, the motor will rotate clockwise. When the motor, the signal is number 2 not running, the motor will rotate anti-clockwise. So that is the setting or the condition or the interpretation between input and output you can set for computer or control system. So the main part is the important one is this one, because without brain you cannot process the sensor, and then you cannot have the signal to send back to the motor or to the other part in our body to do a job. So whatever, because one sensor you can link with another output as well. Instead of motor, you can link with the lamp, for example. Lamp. Lamp is like menthol. So they're blinking, for example. So together with the running, the lamp will blinking, the motor will retract. So you can make or buzzer, for example, buzzer. So the running, you can hear the buzzer, and then the lamp sometimes the blinking. So to tell you that is the running. So you can use the same input for multiple output. That is how we use the because when you buy Arduino, for example, or Python, for example, they have a input. So the important thing you need to find is how much input you have and then how much output you have. So when you design your system, you already know, oh, I only use one sensor. For example, only rain sensor, no other sensor. If you want to use multiple sensor, you need to make sure the output is enough for you. So normally they have 4 input, 8 input, 12 input. So depend to you. So so many input, increase the input, the price of the computer or brain Arduino also will increase the price. So that's why for you, maybe you use one sensor, you can take a minimum one is a 4 input only, or 2 input as enough already. But for output, if you plan to use one motor, you can choose a 4 output also. So that is all the specification of the computers or the Arduino or patterns you want to use. So when you have this one, they have a battery to connect. They also have a PC. They use HDMI, for example, to connect with the computers. Because when you buy Arduino, you need to connect to the computer to do a programming, and then you send the program inside. The program is like you want to make a condition 0, 1 is raining. That is condition number 1. What happen when condition like C language lah, kan? And then you send to the brain. They will because they have a read-only ROM and RAM. Read-only memory. You can write random access memory. So when you do RAM to the RAM to duplicate the instruction there, they will remember the program that you upload into the Arduino or into the computers. So you can use that one, and then you connect that one and you can let the processing begin. So you just wait lah. Like you can see nowadays in the they sell outside in the market like light sensor. When at the night they will light on the sensor, or when the human will come in at your door, they detect the something like a proximity sensor. They use that one. They detect you are in that area, the light will on. So that is for security, for example, light sensor. So that one also inside that one, the simple one, they also have this brain inside. They use multiple chip or computer, the cheaper one. So you can buy anything. You can find, you can make literature to find out. The PLC is very expensive lah, because they use a logic control. They use for industrial, but the cheaper one you can use Arduino. Because Arduino nowadays very famous. You can just buy, and then you can do, they give a sample programming, and you can try. And in the internet also they have a sample, YouTube also they have sample to do a programming. So very easy, Arduino. Python also can. So depend to you, because all this all this thing you need to familiar, you need to study, you need to explore. So you can explore. I suggest to you to buy Arduino or Python, or mini computer if you want, but mini computer is quite expensive rather than Arduino or Python, but cheaper than PLC.
Oh, PLC is the expensive one.
PLC expensive because they use for industrial, but for you it's not necessary, because you just use for experimental lab. But for the future, maybe you want to expand, you want to commercialize, you want to make to patent or to sell it. You can use another computer, not Arduino. You can use, you can change to the PLC, for example. But for now, for this purpose, you can use Arduino or Python. You need to Google that one. I suggest you to find out how it works. But you ask me the connection, sensor and motor, they cannot connect directly, but they have something brain to process. All right.
So for example, if we have a motor like this, do you see my screen, sir?
Okay, you can share your screen.
Okay.
Okay, you can share your screen.
Maybe.
Yeah.
So I'm planning to buy a motor like this, usually used for RCs. Remote control.
DC motor.
Yeah, DC motor. So they have two terminal. This one is connected to, like the connection is how? Is this connected to the Arduino? So?
The motor normally they have a PWM, path width modulation, to control. Path width modulation. So I share my screen first. Path width modulation. So this one, I take one like this. So the signal, they have a 0 volt, they have a straight. That means the motor will not moving. But when you give the 5 volt for the motor, so the path is on off like this. So that is a path modulation. So you can use this voltage control to translate to the rotation, or you can read that that one to transfer to the controllers. So the like this. I guess this one easy to you can see this one on off on off. So normally motor rotation is on off on off. So when they have a speed, then they rotate, you cannot see that one lah. But the signal, the signal read by computer is on off, PNW. That is the term of the signal. So you can use you can find out how to motor connect to Arduino, for example. This one, DC motor connect to Arduino. You can find out in the Google or inside this one how to, because some motor, if you buy, they can directly connect to Arduino, but some motor need the like converters. For example, this one Arduino, they have another converter, but they will, if you buy motor and then from AC or from Shopee, for example, you find out the motor can be directly connect to Arduino Uno, for example, for your project. So they give this one, and then they give the connection to connect directly to Arduino. So some motor you need to do to design electrical circuit by your own, this one, to interpret the PWM to the Arduino. But nowadays, I think no problem. You can find out they give already this solution and then directly connect to the Arduino. But some motor also already do it inside. So you need to read the manual for the motor spec also, because they have voltage. For example, this one. This one, the motor need to do a converter. The converter only transistor, resistor. So this is how you design this one, electrical circuit, to translate the pulse with modulation to the Arduino. So we cannot connect directly to the Arduino. So this one for circuit board for trial, your design for the converters. But after on, you need to build in. You need to make a solder to do the board lah, like this. I find out in internet. This normally later on you need to create this one lah, kan?
The right one.
But in this trial, you need to design your converter by using the breadboard, this one, like this. Okay, you understand this one? So this one you need, you can find, like me find, and DC motor connect to the Arduino. So very easy. When you get that one, because they use a on-off signal. So on, you can on to turn on the motor, off is to turn off the motor. So you can use that signal easily. And then you can increase the speed by percentage. Percentage, this one. Because the percentage, the cycle, duty cycle, 0 if totally off, but 30% is low, 50% fast, 70% is very fast, and 100% is very fast. So this one you can use to control the speed as well by voltage. All right, because when you see the voltage 0, they increase a little bit, the 25%, half 50%, and then up to 5 volt, because the motor is 5 volt, they 100% duties. So that is how the PWM signal for make sure you can control the motors. Okay. So maybe you wonder, you ask a question, how to control the speed as well, instead of on.
Yes.
So they use this term to control the speed, percentage of duty cycle. Okay, I think this one answer your question. You can find the pass with modulation is the signal using inside the motor, but to control this one, this signal in the controller, motor connect to Arduino, DC motor. This one. So you need to have converters, transistor, resistor. You need to have a through this one, and then they will read this one. So this one also sometimes they cut the noise as well, because some signal from motor they have noise. So to differentiate between noise and the actual one, they use a resistor or this one to cut off the noise as well. Okay, but you can find like this one, they already give the inverters or converters. Okay.
In this case, can we control the turning of the motor anti-clockwise?
Yeah, of course. The direction also you can control, because they have 0 to 5 volt or 0 to -5 volt. If you change the direction, they go to the reverse current. So the -1 to change the direction. Motor is you can see the black and red here. So there is also purpose to clockwise and anti-clockwise direction. Okay.
All DC motors can do that. Can
Yeah.
reverse the direction. Oh, okay.
Okay. So I think this one you need to explore DC motor connect to Arduino if you want to use Arduino. Firstly, you need to find out the controller you want to use at the Arduino, Python, for example.
Yes.
Okay. So this one. So Raspberry Pi also okay. Raspberry Pi, Python, Arduino. So I'm not sure which one you want to use. So you can Google, you can find out which controller suitable for your project by Google, by do a literature, and then see the sample in the YouTube as well. Some controller like Arduino, they give some people share their work inside inside the internet or in the YouTube. You can see the sample, and then you can decide, oh, this one so many sample or so many, and they sharing inside the Googles. So you can decide based on that one as well. So if you buy something but nobody share the code and the sample, very difficult as well. So that is how you're learning, because for me also I learned by hobby last time before, because I am from mechatronics, even though I'm mechanicals, but I use this opportunity when doing the project to explore how the connection for to do a better connection. But in Brunei, I think if you show me the Shopee just now, you can find out from Shopee as well if you want. Okay, and this one they use Raspberry Pi. This have a motor controller and a motor. Okay. This one. They call motor driver. If you buy, they have driver. Driver is you don't need to do made by your own connection like this.
Oh, like the breadboard.
Yeah, breadboard. This one you save your time.
Yes.
So up to you lah. If you want to make a more adventurous, you can do this one. You can see, you can do to study how to make a connection to do motors, drivers, to do converter for your PWM. But inside this one, they already have a driver. They have all inside. Just connect to the power, 12 volt and ground, and then connect to the motor here, and then signal come out here to the Raspberry already.
Oh.
Okay, well, this one same to the Arduino as well. So I think not nowadays they have already hobby become the competitors like Arduino, Python's, Raspberry Pi. They have their own market, so they make more easy to user to use as a hobby. When they buy, they just plug in, they can use already. Just make a programming, the code only, because the code is how creative you are. You can make a good code. Okay, but for the connection, they give you already complete. Just plug in. Okay. So when you see in the Shopee also, they have a kit. You can find that kit for a simple, maybe the not cloth hanger, but I think similar to that. You can find for similar tasks like retract or extend the purpose of the project. You can find in the Shopee. They give you already complete set with the Arduino Moto, so you can just modify it to your project. Easy. That is my clue lah. Okay, anything else?
Next question is for the extending and retracting part. There should be like a limit where the extending should happen, should stop.
Yeah, of
how
course.
do I do that?
Of course. You can do by your observation or by your simulation or experiment. So for the rotation, for example, they have 360 degree. Yeah. So when the motor rotate, you can use some gear to change the circle, the length of the retraction. Because when the motor rotate, of course they rotate 360 degree. So that is the maximum they can give you for retraction or extend. So when you make a connection through the link, you need to use transfer gear.
Transfer gear.
Gearing system. So
like transmission.
Transmission. Okay. So when you have gear like this, for example, this one small gear, this one big gear, and then this one link to the motor, for example, motor shaft. This one we rotate, and then this one we transfer to the link.
Pulley.
They have a pulley link like gear like this to retract and extend the bar. So the length based on this gear, is it? Because the bigger gear, they will rotate more slowly rather than the small one. So the small we transfer to this one. You can do a calculation for the length, because you can design whatever length you want based on the gear ratio. Yeah. If you don't have this one, you make a connection direct to this one. Of course, the length very short. Okay. So the link, the gear, they have like this. So this one is based on gear. This one to rotate. This one to make a moving. Like gigi lah. They get to rotate, to move. So the length you need to calculate on it. You can do a try error also. No problem that one. But the gear, I think you can either find a standard gear or you can do you can find the plastic gear from the hobby shop as well, no problem. Because this one not for the heavy duty, you can use as a the project partner. So when you know the concept already, and then you can have that terminology, you understand that one, and then you can make a more robust in the future for the market. But for this purpose of the project, you can design based on lab sample order for the project sample as well. No need to do expensive one to find the steel gears to everything lah. That one expensive, I think. So find the simple one.
For this case, where do I input the length? So how do I tell the motor to stop after a certain length is?
No, this one you control by rotating this motor. When you like I said just now, the motor can rotate 300 degree. Okay, so to rotate the motor, they have a pulse modulation, on, off, on, off, off, on. So, for example, on, off, on, off, on, off. This one until this one only 20 degree they will turn. So off, on again 20 degree. Off, on again 20 degree. So you can count how many degree you want to on off the motors. So when you have a complete 300 degree, you cannot turn it anymore. For this case lah, kan? But if you use the you want to use always turn, just let be on off, continue until you stop the switch. So because this one 300 degree is one turn, 300 degree is another turn, second turn, third turn, until you off the motor or off the signal. But in your case, you can design only from 0 to 300 degrees. Because you want to use a not always rotating. You just want to rotate to go from here to here only. For example, this one not up to 300 degree. For example, only 90 degree. So they will give you this length. But if you rotate this one until 360 degree, they will go beyond that one until here. So that one based on your setting lah. Because you don't want to make continuous rotating for your motor. You just give one signal to do your job and then stop. So better you choose the motor. In the hobby shop also they have a stepper motor, step motor. So either you want to use DC motor or stepper motor, up to you. For stepper motor, you see in the like this. Stepper motor, I show you the stepper motor. Stepper motor. In car control, they use stepper motor. I want to show you the example. This one. Okay, I show you this one lah. Simple stepper motor.
I can't see your screen, sir.
I cannot see.
No.
Okay, I stop the sharing. Wait, I find the stepper motor. Okay, I find it. Okay, you can see my screen? No.
Not yet.
Okay, this one. Oh, sorry. Okay, can see?
Yes.
Okay, I just find in the stepper motor hobby car controller for the hobby like this one. Normally, I use this one only, the small motor, the hobby servo motor. Servo
The
motor
motor is inside.
Yeah, servo motor is a small one. There is also use a stepper motor concept. Step. Yeah, they just use this one. They rotate up, not fully turning, but for turn from here to here for 360 degree. For example, you want to control the steering, for example, they will use this one, and then you can connect the link here. Here you can use here you can use the bar connection to pull the light. You play the car control, remote control car before?
Yes.
So in this one, you can connect to the link to control the shaft, for example. So they use also this one. So
is this the PWM, sir?
They use pass control. Only on off only. On off. So this one quite easy. Why I say you easy? Because when you do you pull this one, you can use only gear. You can connect another gear here, big gear, to this small gear. Okay, and then another gear to the link or rod to make a moving. So that is how you modify it. Because this one very cheap, because you can use for example, servo motor Arduino, for example. This one servo motor, they have Arduino. I image, I go image. So this servo motor, this one gear, already gear. This one you can connect with another gear, big gear. This one they already make a big gear. This one, so you can connect to rod, for example. Okay. So depend to you. You want to use which one? Using servo motor with Arduino, they give you tutorial. You can find out that the project using this one. So instead servo motor, they have stepper motor. Stepper motor are the same. The concept is step by step. So this one, for example, they have a rotating until, for example, they have where is the shaft? This one, you can see the shaft here. This one you can make a gear. They just rotate for like a servo motor, step by step. So this one they have already converter here. Servo motor, they go to the converter or driver control, and then driver controller they give the signal to the Arduino or controller here. Okay. So I think this one you can make a Google how to do a connection between motors, whether you use the motor, servo motor, or DC motor. So which one you want to use based on information or based on literature you do, and you decide that one.
Okay.
So close. Some maybe the YouTube, I think they have some video or some project.
I've seen some of the design also.
You already see?
Yeah,
Okay,
yeah.
okay. So I think no problem because you can see to find and then to find out the best one, because maybe they have a different approach. Like I said to you, that is my point of view, how to do a automation to that to your project. So you can use one to select the sensors and to do connection with controllers, and then connect with the motors. So the motor you want to choose also, you need to find out the best motors also, the suitable motors, because you want to control the link of the extend and retraction of your hangers. So the load also, if you use a dummy project, just a lab scale project, you can use a small load of your motor. So you can use a servo motor or servo motor. But if you want to use the like prototype, you want to show the close hang and then do a traction to your road, you may choose DC motor as well, because DC motor is more powerful to load, to extract your hanger what you design. So you can the objective of the size, the objective, you need to link up with your part or your equipment you want to use. So if you want to make a bigger, if you want to have a robust, you have to find the suitable motor you want to use. You cannot use the small load of motor. They will burn later on. They cannot moving. So that is all consideration. As an engineer, you do a calculation, because based on calculation, you choose that one. Even lab scale also, if you want to make a small one, like lab scale is small, so they have a scale down, and then they also have a calculation for that one as well. When you do enlarge or to do a prototype or do to produce that part, you need to do a calculation based on ratios, based on that one, based on your design. That's why the calculation is very important. So everything you need to start to find, like I said just now, the sensor type, the motors, and then the controller you want to use, and how to extend the retract and extend the link of the cloth hanger. Okay. All right.
So my last question.
Okay.
Let me share my screen. So this is my setup. You can see my screen? So,
yeah.
this is my setup. Basically, I'm using a set of a set of string or a thread. So like this individual orange one is from the top view. So if you pull from this side, this one is in the extended mode already.
Okay.
So the cloth hanger can hang, can dry. So during retraction, this one will pull to the left. The top side will pull to the left. So wait. During retraction, this one, the bottom one will go to the left.
Okay, understand. Yeah.
So everything will go to the left and into the protection shelter.
Okay. Yeah.
So in that case, to link the string with the pulley, is there such pulley that will work for my case? Because I'm afraid the string will slip on the pulley if use a regular pulley. Talking about the linen thread. Yeah, string like this. How do I make them not to slip on the pulley?
I think if you want to use like that one. You have a motor here to control. So in motor you have one like you can design, you can have a like stepper motor just now, they have this one, like this, sorry, this one, they have a hole, that one. Okay, when you use this one you can make a like a stopper for your string, like this one. Okay, so when move this way, they will pull all this one, because this one will rotate like this, like this, like this. So they will pull until this one. So whether the length you need to see lah, because when they will turn from here to here, there is only the length they can be retract, or from here to here, back to here, they will extend back. So that one based on your creativity, based on pulley also. If you want to make up like this pulley, like this one pulley, and then the string will go inside this pulley. So you need to think how to design your pulley lah, because maybe your pulley like this, and then the string put here. There is the view, from side view, there is string, so maybe they not slip. So and then the string also, then the length of the rotation also, they will depend to the how far or how much they will turn to pull the string, because this one you have a hanger cloth, so maybe from this side to this side is the apple, the areas, the gray area, the only area you can pull in your string inside the pulley, because until this one they will stop already, because you have a hanger. Okay, so this distance you need to consider as a shutter distance, because this one, D distance, here D distance is the same, because this is a shutter, for example. So when you pull, this one is outside. The raining coming here, you need to pull from D area, this one, go inside this one. So this area only represent for this one, to make sure the area covers by your shutters or your house area, whatever lah. Okay. So the D area distance is represent that one. So same to this one also. This one D distance can only move this one to cover the D distance here. This is outside the house. Because when the cloth hanger retract until here inside, they give only this area for your clothes, and then they go back to this area. So you can make a calculation or design based on that one lah. But this one you can use a more longer length for this type of things to make sure the distance is wide. So that is how your creativity to design to make sure the distance can be controlled based on D distance, this one. If you use string lah, but if you use like zigzag, for example, this one different things as well. So this one maybe you need to consider to retract this one using a stepper motor for each this one to retract together, because when the stepper motor, they have this thing, they can go to this side, they will
close,
and then you go to this side, they will open. So easy. When you make one for this one, you can make 2, 3, 4. But all when you make a parallel connection or series connection or parallel connection, you can control different way. So whether you use series or parallel, you can decide for the opening. So based on, because this one I just heard from you, so that is my point of view to give comment for that one. Either you want to use pulley, you need to design this one also, no problem, because pulley also they have this one curve. So that one I cannot decide for you. Can make a literature, make a studies for that one, simulation, which one you want to use, either this one or this one, or either this type. So based on your condition or based on your design. Okay, but that one I saw your design just now, your purpose. This my reaction for this one, the suggestion for this one. You can choose, and then but the most important thing. So this one also you can use this type, this rod, and then this one can control by the teeth of gear to rotate. So this one also makes sense to do it. Not easy, but the most important thing is the brain, and then use the signal, and then input signal and output signal. All right. So that is our discussion today to you, and then you can make a propose to upgrade or to revise back your suggestion inside your proposal just now, because when I see this connect direct sensors to the motor, that is cannot be. You have something in the middle like a controller, so you need to use that one also. And then my suggestion is for easy to you can make a flow chart for start.
chart.
Then, for example, this one process. Process. So process is the for controller. Either rain or not rain. Rain. This one, for example, rain. This one not rain, for example. So they have another process. They have another process. So rain, they go for the motor extend or retraction, for example. This one, motor not rain, motor extend back. We turn another clockwise, for example, and then this one motor until clockwise for retract when the raining, not raining, they give extend. So you can use a flow chart to make your process easy to understand.
Oh, okay.
That is how you can use flow chart. Because this one different thing, this one different thing, and then this one. So from there you can make a algorithm when during the programming. All right.
I think that's answer all my questions.
Okay. All right. Anything? All answer already?
Yes, all done.
Okay, good.
Thank you very much, sir.
Okay, I
Thank you
stop.
for your time.